Good afternoon, I'm Mr. Ish. Thank you for joining me for this video. We have here a power series n equals 1 up to infinity, n factorial times 3x minus 1 all to the power of n. You have to evaluate this. Determine those values of x for which this series is convergent. You know, in terms of what I've presented for power series, there are three cases. Very quickly, case 1 is such that x equals a. There's only a single value for which you have convergence. Another case, you have x is equal to, well, let's just put it in interval notation. Any value of x, you'll have convergence. You have such a broad radius of convergence. Here, your radius of convergence is just 0 because there's only one value. Beyond that value, there is only divergence. Here you have every value. Your radius of convergence is always infinity. All values give you convergence. Here all values give you divergence except for that one specific value for which you have convergence. That's your case 1, case 2, case 3. There's a select values for which you have convergence, and you know, here you have that interval notation. We don't have to be too specific with what I'm showing you here because I'm only reviewing very quickly 1, 2 and 3. I have presented you several examples with regards to that. Your radius of convergence is a certain number, it's a finite number. Your interval of convergence is a certain finite notation. Let's look at this question here without any further digression and see which of these cases it falls under. In all instances, employ the ratio test. You're looking at the n plus 1 term with regards to that. Wherever you have n, you'll put n plus 1 and then you'll impact everything with regards to that. Again, you have a power series. And then you know you have to find your anth term, which is usually your original function. You have here n factorial and then you have 3x minus 1 to the power of n. You know you're doing the ratio test, you might as well do the ratio right over here. A shortcut I've shown you in the past, n plus 1 factorial is always equal to n plus 1 times n factorial. You can utilize that and you might as well. Open things up and utilize your shortcuts and your properties of exponents. You'll have n plus 1 times n factorial. This is all here in the numerator. 3x minus 1 to the power of n and 3x minus 1 to the power of 1. Now bring in your denominator part. This is just n factorial and 3x minus 1 to the power of n. Cancel those items which can be cancelled. That cancels, that cancels. Let's come back over here. The ratio test is always limit as n approaches infinity. What remains? I have this item remaining, I have that item remaining. That item I'm going to push outside right here, 3x minus 1. Remember, all of this here is under absolute value. I have n plus 1 coming over here. This is easy evaluation. Remember, think about the direct substitution property. For those types of functions where this a value is in the domain of those and this is in a domain of this, and those types of functions include your polynomials, select trigonometric functions, select rational functions, and select radical functions. You can always just substitute this right here. What are you really looking at in terms of a limit evaluation? 3x minus 1 and then infinity. All of this is generating infinity. This infinity generally corrupts your entire series and tells you that your series is divergent for all values of x. For all values of x, you have divergence, except there's a single value which you would not have divergence. If you were to somehow zero this out, then you'd have 0 multiplied by infinity, then you'd have 0 in terms of limit evaluation, then you would have convergence. This is the case 1, as I was mentioning earlier, or as I was alluding to earlier. This is a series which is of case 1 type. All values of x, when plugged here into your series, will give you divergence, except there's a single value. If you determine that value, you'd have convergence. We have to determine that. You can determine it, it's not hard. When you're looking at this, you have that case 1, which I've shown you, it's case 1. Your radius of convergence is going to be 0, and we'll talk about that momentarily. Your interval of convergence has to be determined. Take this item right here, 3x minus 1, you can keep an absolute value equal to 0. 3x minus 1 is equal to 0, 3x is equal to 1, x is equal to 1 over 3. If you take this 1 over 3 and you plug it right over here, you'll have a 0. In terms of your limit, here you'll have a 0. That 0 will zero out your entire this portion with regards to the limit. This thing will now tend towards 0 and you'll have convergence. How do you write your interval of convergence? You write it as this, 1 over 3. You can put in curly brackets. How would you verbalize? Your verbalization in terms of your answer is this. For the power series, your series is divergent for all values of x except for this. If x were to equal 1 over 3, you see convergence. Very quickly, before we end this video, let's talk about our radius of convergence, which I like to call spread. Because I've mentioned that in my previous video, I call it spread. If I have a single x value which is 1 over 3, I have on either side no spread, because any value on either side of 1 over 3 is not going to zero this limit out, or that the limit won't zero out. Any value outside 1 over 3 will always give you a divergence, especially by means of this limit evaluation. Again, you're given this question on your exam, your answer should be this. You have a radius of convergence of 0, you have an interval of convergence of 1 over 3. You can verbalize everything as such. Your series, your power series is divergent for all values of x, except if x were equal to 1 over 3, you see convergence. And that would be it for this video. We will keep it to this one single question. Here we're seeing case 1 style of question with regards to power series. Thank you for watching.